हेलो। हाँ सर, कहाँ पे हैं आप? चलो, कोई बात नहीं, मैं आ रही हूँ। मैं आ रही हूँ। चलिए सर।
Okay, welcome back for ICT lecture. We were talking about silicate industries. We just saw about the manufacturing of glass, different types of glasses, and the process description. Now moving ahead to the another form of silicate industry, which is cement. So what is cement? Cement is a mixture of calcareous, siliceous, and argillaceous and other substances. Cement is used as a binding material in mortar and concrete, etc. Chemical composition of cement is lime, silica, alumina, iron oxide, gypsum, and its relevant percentage. Lime 63, silica 22, alumina 6, iron oxide 3, and gypsum 1 to 4%. Types of cement, as I said, we have different types of cement like ordinary Portland cement, uh, rapid hardening cement, extra rapid hardening cement, sulfate resisting cement, quick setting cement, which we use for household appliances like white cement and everything. Then low heat cement, Portland pozzolana cement, Portland slag cement, alumina and draining, super sulfated, masonry cement, expansive colored. These are the different types of cement. And now the following slides are going to talk about every type of cement. What I would suggest is you can read through it instead of me just reading it out. You can read through the properties and the description of each type, like ordinary Portland cement, its chemical composition is given, and functions of the cement manufacturing constituents. What are the cement manufacturing constituents? We have the 5 constituents like lime, silica, whatever constituents we have seen, alumina and all. We will see about that function. What is lime used for? Lime forms nearly two-thirds of the cement. Therefore, sufficient quantity of lime must be in the raw materials for the manufacturing. its proportion has an important effect on the cement. Sufficient quantity of lime forms dicalcium silicate and tricalcium silicate in the manufacturing of cement. Lime in excess causes the cement to expand and disintegrate. What is the role of silica? The quantity of silica should be enough to form dicalcium silicate and tricalcium silicate in the manufacturing of cement. Silica gives strength to the cement, and silica in excess causes the cement to set slowly. Alumina supports the cement to set quickly to form the concrete, and lowers the clinkering temperature. Clinkering is forming lumps, okay, clinkering temperature. Then alumina in excess reduces the strength of the cement. So we have the problem associated if it is used in excess, and we have its own property as well. So lime, उसका function क्या है, and lime excess में जाएगा तो क्या होगा? Silica का function क्या है, and silica excess में जाएगा तो क्या होगा? Same way alumina, उसका function क्या है, and excess में जाएगा तो क्या होगा? And iron oxide gives color to the cement. Magnesia, it is again used in giving color to the cement, and magnesium in excess leaves the cement unsound, like it is not good. And calcium sulfate and gypsum, at the final stage of manufacturing, gypsum is added to increase the setting of the cement. Okay, to rapid setting में gypsum ज़्यादा होगा. Then rapid hardening cement एक दूसरी category है, दूसरी type of cement है ये. Okay, so as I said, you can go through the types of cement yourself. First हमने देखा ordinary Portland cement, उसके properties and उसके composition. Next है rapid hardening cement, उसके properties and उसका composition. Then extra rapid hardening cement के बारे में है यहाँ पे. Then sulfate resisting cement, quick setting cement, its properties. So यहाँ पे देखो, low heat cement is also here. Portland pozzolana cement. हम ये pozzolana का बारे में detail में देखेंगे in the next presentation. And Portland slag cement, high alumina cement, air entraining cement, super sulfated cement, masonry cement, and then you have expansive cement, colored cement, and white cement. So ये सारे types है. You can read through them. Very simple it is. I'll show you the Portland cement and its complete description now. Okay, as we discussed cement, what is cement is given here. Now, classification of cement, we have natural, pozzolana, slag, and Portland. Portland cement composition वहाँ पे भी है, and this is the same here. Now, raw materials हमने वहाँ पे भी देखा, calcareous, then argillaceous, gypsum, and other than that, you need powdered coal and fuel oil for generating required temperature. Manufacture of Portland cement schematic representation. तो यहाँ पे limestone and other minerals, that is raw mixture milling यहाँ पे एक बार उसे mix करेंगे. Then raw materials storage silo here. From the silo, it is sent to the rotating kiln. In the rotating kiln, it is mixed again. It is sent to the clinker silo, जहाँ पे वो lumps form होते हैं, and from there it is sent to the cement mill. Cement mill में क्या होगा? Additional ingredients like fly ash, slag आप यहाँ पे add करते हो. And from the cement mill, it is sent for packaging, transport, and consumer तक जाने के लिए. Now, manufacture of Portland cement. Portland cement में क्या-क्या steps है? Crushing, mixing. Mixing में दो process है, wet process and dry process. I'll show you the video on both the processes. What is the difference we will see. So, in the manufacturing of Portland cement, we have two mixing process. One is wet mixing, second is dry mixing. Then it is mixing is followed by grinding, followed by storage. And you have basically three categories: burning, grinding, and packaging. So the first one is crushing section. What happens? You get limestone, it is crushed, it is grinded, it forms a raw meal, it's like a slag. From there it goes to the kiln, from the kiln to the clinkers, and you have additives here, and then grinder, and then the cement. This is crushing. Like here, the second portion is crusher. So what does crushing do? This is the first step in the manufacturing of Portland cement. Jaw crushers of various sizes are employed for the crushing purpose. Raw materials are crushed by crushers till the size of the raw material reduces to almost 3/4 of an inch, and it is then sent for either wet process or dry process. Now, wet process is universally employed, but we have also dry process. Then mixing wet process. So wet process में क्या होगा? Calcareous materials are crushed, powdered, and stored in bins. Argillaceous materials is mixed with water and washed. This removes any adhering organic impurities. Powdered calcareous and washed argillaceous materials are mixed in proper proportions to get a slurry. Chemical composition is analyzed and corrected if necessary by addition of deficient materials. This slurry is then fed into the rotary kiln. Now, In the mixing wet process, there is a formation of slurry because of the addition of water. But we will see what happens in the drying. Hard raw materials like cement rock or blast furnace slag are first crushed to 50 millimeter pieces in ball mill and then dried and stored. Crushing is done by gyratory crushers and drying is done by rotary dryers. Separate powdered ingredients are mixed in required proportions to get the raw mix, which is then fed to a rotary kiln. So here it is kept dry. Nothing is wetted or nothing is having addition of water here. Then grinding, either you can use ball mill or you can use tube mill for grinding. Then storage of ground materials. The storage materials, almost 30 to 40% of water is stored in separate tanks equipped with agitators. क्योंकि क्या होगा, if you don't agitate, what will happen? The cement sets itself. वो set हो जाएगा, तो वो hard हो जाएगा and it is of no use. So if you want to store the wet cement, you need to keep on agitating it. This step is followed by process of burning. तो यहाँ पे देखो, you have your raw material hopper, screw conveyor, यहाँ पे rotary kiln है जिसमें clinkers and वो सब बाहर निकल जाता है यहाँ से, which is then dust chamber से collect कर सकते हो, and you have a burner which keeps the cement away from setting. Okay, and यहाँ पे ऐसा है. Now burning operation के बारे में यहाँ पे दिया गया है, you can read it. Burning zone में दो है, एक है drying zone and calcination zone. So what is roasting and what is calcination? Roasting, the concreted ore is heated in presence of air. It is used to convert sulfide ores into corresponding metal oxide. Sulfur dioxide gas is evolved. The concentrated ore is heated in the absence of air. It is used to convert carbonate ores into corresponding metal oxide. Carbon dioxide gas is evolved in the calcination. Then burning zone, there is also another zone called as clinkering. So you have first is roasting, calcination and clinkering. Clinkering, this is the lowest portion of kiln with a temperature of about 1400 to 1600 degrees Celsius. Lime and clay nodules melt with chemical fusion and gives calcium aluminates and silicates. These silicates and aluminates then fuse together to form small hard stones called clinkers. As I said, they form lumps, which then fall down from the lower end of the kiln. Then constitutive composition of clinkers. Clinkers में क्या क्या होगा? So these like dicalcium silicate, tricalcium aluminate, these are the composition of clinkers. Clinkers ऐसे दिखेंगे, lumps जैसे, छोटे छोटे पत्थर जैसे. तो ये form होगा, उसके बाद ही आप उसे grind करके cement form करोगे. So after clinkering, you have grinding. Grinding, first you put the retard जिसमें gypsum आप add करोगे to prevent quick setting. जल्दी set ना हो, इसलिए आप gypsum ऐड करते हो. Gypsum, sorry मैंने पहले शायद आपको ऐसे बोल दी थी कि gypsum helps in fast setting. Gypsum is slowing the setting thing. Okay, so gypsum retards the dissolution of tricalcium aluminate by forming tricalcium sulfoaluminate, which prevents quick setting. Okay, then you have dispersing agent. Sodium salts and polymers of condensed naphthalene or sulfonic acid are added to prevent formation of lumps and cakes in the cement. Waterproofing agents are also added. उसके बाद packaging and उसके बाद Portland cement का final composition and specification of Portland cement, again what it's soluble nature, weight and everything. Other specific requirements for Portland cement, first is fineness, next is setting time, initially 30 minutes and finally not more than 600 minutes. 600 minutes से ज़्यादा नहीं होना चाहिए, set हो जाना चाहिए. Then tensile strength, compressive strength, heat of hydration and soundness. Soundness is the ability of a cement to maintain stable volume after setting. A sound cement resists cracking and disintegration. ये है soundness. Then there are two technologies. First जो हमने पहले देखा भी horizontal kiln technology था. ये जो है ये vertical shaft kiln technology जो recent है and most advanced है. Vertical shaft kiln technology has been successfully employed by many cement plants. The VSK vertical shaft kiln have pan modulizer and pelletizer. The uniform pellets are so formed can be fed into the vertical shaft kiln and cement can be produced. Proper proportions of raw cement must be taken into to get good quality of clinkers. You have two processes in this. First is black metal process and fuel slurry process. This is about the vertical shaft kiln technology. And what are the advantages of vertical shaft kiln technology? No dust discharge in the atmosphere due to pellet formation. Clinker clogging is avoided because no low melting constituents are formed. Wearing of grinder machinery and cost of grinding is removed. Plant is quite compact. Vertical is quite compact and you just need headspace. You don't need elaborate expanded room. You just need a headspace more. Chemistry of setting. What happens when the cement is being set? So initial setting, it is mainly due to the hydration of tricalcium sulfate. tricalcium aluminate and gel formation of tricalcium aluminoferrite. Dicalcium silicate and also contribute to the initial setting. Final setting कैसे होता है? Mainly due to the formation of tobermonite gel and crystallization of calcium hydroxide and hydration of tricalcium aluminate. The concrete can neither be molded into any shape nor it can be remixed. एक बार वो set हो गया मतलब आप उसका कुछ नहीं कर सकते. And chemistry of hardening. तो हमने जो देखा वो chemistry of setting है, initial setting and final setting. Hardening क्या होता है? During hardening, the solid cement material begins to gain strength. It depends upon the chemical combination of cement and water. Hardening starts with great speed, but finally its speed reduces. The hardening of concrete stops and it is dried out. The hydration reactions are exothermic and the volume of cement increases with hydration. Hydrated cement dissociates on heating by destroying the bond and on which the mass was held together. So this is about the cement. Now we will see about the wet. This is about the Portland cement, and now we will see the video as I was telling you on wet and dry process. First, we will see the dry process of dry mixing of Portland cement.
Also an ingredient in the mortar that masons use the terms cement and concrete. Cement is a fine gray powder that's used to make concrete. It's also an ingredient in the mortar that masons use to lay brick and stone. Cement also goes into soil cement, a material that's used in paving roads, building dams, and lining reservoirs. The action begins at the limestone quarry. The limestone near the surface has a high content of the minerals silica, iron, and aluminum oxide. Deeper down, the limestone is more pure, containing less of those minerals and more calcium carbonate. The plant uses both types of rock, altering the proportions to make different types of cement. Workers drill holes in the rock wall in which they plant powerful explosives. For safety, the workers have to position themselves behind the area they're blasting, maintaining a distance of at least 50 meters. After the explosion, loaders move in. They transfer the limestone rocks to 50-ton capacity dump trucks. The trucks then haul their cargo to the cement plant nearby. At the plant, the trucks dump the rocks into what's called the primary crusher. The rocks can be as big as a piano. The primary crusher reduces them to about the size of softballs. There's a constant spray of water to keep the dust from billowing up and settling on the chutes. From there, a conveyor transports the rocks to the secondary crusher. It reduces them further to about the size of golf balls. Rock high in calcium carbonate and rock low in calcium carbonate are crushed separately. Now it's time to mix the two. The ratio varies according to the type of cement they're making. This overhead machine called a tripper makes piles of the required proportions. They call this the raw mix. Then a reclaimer loads the raw mix into a grinding machine called a roller mill. Depending on what minerals are already naturally in the crushed rock, the factory adds extra minerals such as silica and iron. Certain types of cement also require aluminum oxide. The roller mixes and grinds the ingredients uniformly, producing a dry rock powder called the raw meal. Now the powder goes into a preheater. The temperature of the powder is 80 degrees Celsius upon entering. Within 40 seconds, it gets more than 10 times hotter. This begins the process of bonding the minerals together so that they'll later harden when hydrated with water. The preheater is equipped with what's called a flash calciner. In about 5 seconds, it removes 95% of the carbon dioxide in the powder through a chemical reaction. This isolates the lime, which is the most important element in cement. From there, the powder moves into a rotary kiln, a huge cylindrical furnace. It's set at an angle so that the powder moves from top to bottom a distance of 49 meters. The kiln rotates about 2 turns a minute to ensure the material travels through at the right speed. The burner's gas flame at the bottom reaches a scorching 16 to 1700 degrees Celsius. As the powder approaching it reaches the 1500 degree mark, it fuses into pieces about the size of marbles. These pieces are called clinker. As the clinker leaves the kiln, large fans cool it down to between 60 and 80 degrees Celsius. It's important to cool the clinker quickly in order to have quality cement. From here, the clinker goes to the storage area. The last stage of cement making is called finish grinding. They add some gypsum to the clinker. The precise amount varies with the type of cement they're making. Gypsum delays the cement's setting time so that it can be worked for up to 2 hours before hardening. The cement mills are called ball mills because they contain metal balls, about 150 tons of them in the largest mill. As the mill rotates, the balls crush and grind the clinker and gypsum into a fine powder.
Now we will see the wet process. This was a dry process. Now the wet process.
The limestone and clay occur together in our quarries at Cape Foulwind. The quarry trucks deliver the raw materials to the crusher, where the rock is crushed to smaller than 100 millimeter, 4 inches. The raw materials are then stored ready for use. Stockpiles near the kiln where pre-blending takes place. About 80% limestone and 20% clay are ground in ball mills with water, producing very fine, thin paste called slurry. The chemical composition of the slurry is very carefully controlled by adjusting the relative amount of limestone and clay being used. The slurry is stored in large basins ready for use. The slurry is fed into the upper end of a rotary kiln, while at the lower end of the kiln, a very intense flame is maintained by blowing in finely ground coal. The slurry slowly moves down the kiln and is dried and heated until it reaches a temperature of almost 1500 degrees Celsius, producing clinker. This temperature completely changes the limestone and clay to produce new minerals, which have the property of reacting with water to form a cementitious binder. The hot clinker is used to preheat the air for burning the coal, and the collate clinker is stored ready for use. The clinker is finally ground with about 5% gypsum in another ball mill, producing cement. The gypsum regulates the early setting characteristic of cement. The finished cement is stored in silos, then carted to our wharf or packing plant facilities.
Okay, so that was about the wet process as well. Now we have finished the second chapter. Let me just show you the syllabus. Okay, so this is your syllabus screen. So in the sulfur and silicate industry, we have seen mining of sulfur, we have seen the fresh process and finish process, the different sources of sulfur, how the pyrites and everything were the sources, and manufacture of sulfuric acid by contact process we have seen. Now we have seen also the glass and cement industry. So second chapter is over. When we meet on next, we are meeting on Monday. So when we meet on Monday, we'll be discussing about the fertilizer industry, where we'll be talking about nitrogen fertilizers and everything. So we will meet on Monday at 10 o'clock with this topic. That's it for today. We will end the meeting. Thank you. I'll also upload the material in the e-content. You can keep reading from these slides also. Apart from Dryden, if you have time, you can refer these slides and PPTs which I'm giving you. Okay, so you can exit the meeting.